sugars, carbs, can make energy without oxygen, but fats must have oxygen, aerobic, in order to make energy. But the biology is how our body converts macronutrients, carbohydrates, fats, or proteins, into usable energy, which is ATP. I'm not going to get into all the technical names of all of this, but basically with the high intensity workouts, we're going anaerobic. And anaerobic means we are functioning without oxygen. Anaerobic means without oxygen. When you are operating in an anaerobic state, the only way your body, your cells, can make ATP is with sugars, glucose, carbohydrates, glucose. That's the only way. And your body pulls those sugars from your liver and from your muscles because that's where they're stored. This is all cellular biology for all human beings. The only way to make ATP in an anaerobic environment is using sugar. That's it. Okay, and this is why after these high intensity workouts and even like sprinting in your triathlon or going too long, when you're in that anaerobic state for too long, your muscle glycogen drops, your blood sugar drops, and that's when you hit the wall. Okay, however, in the base training that I described earlier, in the base training or the other video, depending on how I separate this all out, when you're base training and you're fully aerobic, that means with oxygen, then your body can primarily use fats to convert to energy. And fats are far more energy dense and far more efficient as a fuel than sugars. Actually, and when I say sugars, I mean the carbs, the sugars, the glycogen. I think it's for every glucose molecule, you get like 2 ATP molecules, but for every fat molecule, you get like 28 ATP molecules. So fat is really the most efficient source of energy. Okay. So I know a lot of people, and for the last, with the whole Paleo Atkins diet world, everyone's like, I got to get my protein. I got to get my protein. I understand you want your protein, and if you're lifting a lot of weight and doing a lot of resistance training, yeah, you need protein to grow those muscles and repair everything. But protein is actually the least efficient fuel source. Okay. So for a glucose molecule to get converted into an ATP energy molecule, to convert glucose into ATP, it's really fast, because this is what you need when you're like, you're on the plains and you're a gazelle running from a cougar. You need fast energy, and that's why carbohydrate sugar is so quick to convert to ATP energy, so you can run away and survive. Okay, and you're anaerobic when you're running away because you're hyped up, scared for your life. So with fat, you need full oxygen. The only way you can convert fat into ATP is in the presence of oxygen. That's aerobic. Okay. This is just cellular biology. This is just how it works. It doesn't matter who you are. If you're Homo sapien, this is how it works. This is just the science. Okay. Now everyone's all hyped up about protein. I got to get my protein. I got to get my protein. Well, in order to turn protein into usable energy, ATP, it's a lot of work. And in fact, you actually need like 1 or 2 ATP molecules in that chemical reaction with the protein, which gets converted to an amino acid. You need 1 or 2 ATP molecules to make ATP molecules in the presence of protein. It's a very complicated process. Your digestive system is really working hard. And oh, by the way, when you're converting protein into ATP energy, you also need a lot of hydrogen molecules in order to make those reactions happen. And I'm pretty sure we get those hydrogen molecules from water. Okay, so this is why you see the bodybuilders and everything always drinking like massive amounts of water, because they're eating a lot of protein. And in order to metabolize that protein into usable energy and to repair all that muscle breakdown from the resistance training, you need a lot of hydrogen. So you need even more water than usual. And it takes a long time. It takes a lot of chemical processes. And oh, by the way, in terms of macronutrient efficiency, and again, everybody's on this protein kick for the last 10 or so years, it's totally incorrect, because 1 gram of carbohydrate is 4 calories. It doesn't matter if it's table sugar or if it's a sweet potato or if it's pasta or rice or bread. If it's a carbohydrate, 1 gram is 4 calories. If you're talking about a protein, 1 gram of protein, it doesn't matter if it's fish or beef or whey or pea protein, doesn't matter if it's animal protein or vegetable protein, 1 gram of protein is 4 calories. That's the same as a carbohydrate, okay? But 1 gram of fat, doesn't matter if it's animal fat, vegetable fat, like, avocado, fruit, vegetable fat, doesn't matter what kind of fat it is, 1 gram of fat is 9 calories. That's more than double. So fat is the most energy dense macronutrient we have, and a carbohydrate, including sugars, and a protein are both only 4 calories each. So if you really need calories, or if you're starving, your best source to survive, well, if you're in a starving situation like on Survivor or Alone or Naked and Afraid, they all talk for so long, so often they talk about, oh, I gotta get my protein, I gotta get my protein. No, you're in a starving situation, so you need any kind of calories at all. It doesn't matter what it is, you just need food, okay? But if you can choose which food, the best food in these starving situations, the best macronutrient is a fat, because it's more than double calorie dense, double the energy as a carb or a protein. And again, take whatever you can get when you're in a starving situation. But when we're talking about just energy and metabolism, this is why I think a balanced diet, and again, everybody's got to figure out what works for them. What works for one person doesn't work for another. Someone who really likes a vegan or vegetarian diet, it might not work for them on a carnivore or a keto diet. But someone on a carnivore diet, like when I eat a lot of vegetables or grains, I get so bloated, and I've talked about this in other videos. It hurts my stomach. It's like my microbiome or my stomach acidity or whatever it is doesn't work as well with those higher carbohydrate diets, okay? But when it comes to how these macronutrients are used and how your body uses them, the only way to make energy from a macronutrient is sugars, carbs, can make energy without oxygen, but fats must have oxygen, aerobic, in order to make energy, and proteins are just so much more complicated and require ATP and more hydrogen atoms in order to make usable energy, and it takes so much longer. I think I read somewhere, it could be something like 6 hours from when you ingest protein to be when it becomes a usable energy source, ATP. Okay, so this is what I've learned. This is how I've trained so many athletes and non-athletes, and what I do for myself every year. So every year I go through another base training phase, another 12-week, 3-month cycle of this low intensity base training, the way I described earlier, this lower heart rate, very easy training, in order to reprime and recalibrate my body.